Alright, so we got here a grinder put together by me and the boys. Mitch, would you like to tell us anything about the grinder?
Yes, I would love to. So right here we have our power supply, 12 volt DC, and it powers our Arduino that we have here. Pretty simple code. We built a shield to minimize the need for wires. Yeah, so that powers the feed rate system. You can change the speeds either on the board itself via jumper cables, or you can change it directly from the code. We did some testing and figured out what feed rate was optimal, and we just hard coded that into the program itself. We have two motors in parallel, so that means that current is being split between two of them, so we're getting about half power from each motor. In the future, what we could do is run those both off their own IC so that they become more powerful, and we can actually compress plastic better with the
Next up, we've got the Harbor Freight drill here. It's got the little Tommy gun handle for extra support, which we screwed into the reinforced wood here. Cut these from a piece of sheet metal, the same sheet metal as this, as it were. You can't really see it from where you are. There's a shaft that goes through here about like this. In here. Have a look on the inside so you can see the shaft connected to the drill. Into these nice saw blades in there from Harbor Freight also. They're welded onto the shaft individually. It was quite the experience.
Alright, so to do our housing we chose to use OSB and some 1x4s and 2x4s up in here. We chose not to go for like a metal system because one of cost limitations, as well as we wanted you to be able to make this design on your own, and you probably need some more heavy equipment to cut that metal and get it shaped down so it doesn't hurt you. But we chose to use the metal, or the OSB. We put in a nice little window so that you could easily put your cups and plastic into here if you want to get on in there. It's also a safety measure, so then you don't end up hurting your hand trying to push it in there. We have our 14 saw blades in there, as well as they're all welded to a 1/2 inch. So when we're doing our project, we have our electrical component that's for our feed rate. So you take your cup and you put it on in here. Oh, close it, and our feeder will push it on in there. And when after it's grinded it all up, we get our little box down here that collects all of our pieces. And we were shooting for wood chip sizes, so we've got our nice little tiny ones.
Well, that's me.
And our sort of French fry.
So in the future, we would like to replace the welds with spacers and a keyway so that we can more easily interchange each blade if it gets messed up, rather than trashing the whole blade system. And we'd also like to put the blades closer together so that we get a smaller output.
Go.
So one of the shortfalls we had with this project is the initial mounting we had with this drill. We had the handle coming down here, and it was mounted similarly to this down here. And the issue with that design is that when we put a heftier water bottle in it, it caused the whole motor to torque, and the drill spun and allowed it to torque against the handle, which, because the water bottle was so strong, it actually broke the drill. And we solved that by tossing on this handle and attaching that to the housing itself. Another shortfall we had is that we used wood teeth for the blades to shear the plastic against, which you can kind of see in there. if we were to do this again or in the future, we would like to create metal teeth, so it would allow a stronger platform for the blades to shear against and be able to shred the plastic better.